All right, and we're back. It's COMP305. It's the winter 2016 semester, and it's week 3, lesson 3, part 1. And we're going to continue our little demo for our 2D game, right? Because I want to try and prepare you for your assignment number 1. For most of you, this will be okay, but again, I highly recommend doing the video, the tutorial online. And I'm always going to be probably referring to you to some kind of tutorial online in addition to what I'm showing you, only because there's only so much time I have to show you, all the stuff that you need to know. I'll do my best to give you all the stuff. And remember, there's also a bunch of videos that exist here up on my YouTube channel, so you can always go up there and kind of do a preview of what we're going to be talking about. And for the most part, I'll stick to what I did last semester, but there's always going to be a few changes because Unity is changing, right? For example, Unity is at 5.3 now, and in March it's going to go to 5.4, right? So that's going to be a major change, that major release in March. And you can always look at major releases if you want to see what the releases are. If I say, Unity, as an example, 5.4 release date, right? That's, because this is the main tool we're using. You can look at the Unity roadmap here, and it'll show you all the things that are changing in Unity 5.4, right? So 5.4, they're going to add things, if I'm not wrong, they're going to start using things like tile mapping and so on. That's what they promised anyway. And it looks like they moved it to 5.5 now. So it looks like by 5.5, they're going to start using things like 2D tile mapping, smart sprites, all kinds of additional things for 2D. You can see that there's a whole targeting of 2D, making 2D games, because 2D games and platforms are really popular still, right? So you can see the changes in 5.4, so there's quite a few changes going on. And there's little micro releases between 5.3 and 5.4. So you might see 5.31, 5.32, and so on as we move towards March and June, right? So because of this stuff, right, because of these changes, right, as we move forward, you're going to see that there's going to be some changes in the videos that we make. Now, obviously, the 5.5 June release won't affect you because you'll be done the course, right, by then, way done. But the 5.4 release, if you're using Unity 5, may affect you. So just FYI, look for these releases as they come forward. I'll probably be upgrading to 5.4 as we get closer, just to keep up with everything else. Okay. Let's go back to what we were doing. So again, from last day, we have this. I'm just bringing up COMP305, the winter 2016 mail pilot, and you can find that on GitHub if you were to go to our GitHub. And we have a GitHub repository here. So if I go to Centennial College, and if I look for COMP305 winter 2016 mail pilot, click there, and you can download this project structure, and this is up to date. If I've done anything, if you want to keep up with me, you can certainly download this. Like I mentioned earlier to some people, this example is for Unity 5. So if you're using Unity 4, you can use the code from this example pretty much the way it is, with some minor changes, and you can also use the assets. This definitely you can do. You just download or drag and drop the assets, all these assets, audio, fonts, sprites, and so on, into your scene, because they're not going to change too much, right? But the rest, in terms of the scene itself and everything, you may have to recreate. Okay, so just be aware of that. You can't just double-click and run a scene from Unity 5 to Unity 4. There are backwards incompatibility issues, breaking changes that'll stop those things from happening. Okay. All right, so we're using this one here, and remember what we did last time, right? So we just made the ocean run. I got my script window up here in MonoDevelop. On the Mac, I'm using MonoDevelop. On Windows, it's a great idea to use Visual Studio 2013 or 2015 because it's got a pretty good editor, and with some there's code coloring, code hinting, all kinds of stuff that it comes up with that's really cool. So I totally recommend if you have a chance to do that. And you can modify your editor like I showed you last week. Just as a recap, if I go to File and Unity Preferences or Window Preferences on the PC, you can see that you can choose my external tools. Mine is MonoDevelop, but I can also choose other ones. If I browse, I can choose another editor of my choice that kind of does some code hinting. For example, Visual Studio Code will work just fine for Unity. Now, Now, is it as good as MonoDevelop? You know what? I still prefer MonoDevelop if I was going to choose between Visual Studio Code and MonoDevelop. If I was going to choose between Visual Studio 2013, 2015 and MonoDevelop, I think I would choose Visual Studio. It's just way more code hinting. There's a lot more support in that framework. And that's why the new bundled versions of Unity come with Visual Studio 2015 Community Edition. They almost like ask you to install it if you do that, right? Okay, cool. So we've got our ocean, and notice this is the ocean. If I click on ocean in my hierarchy, I'm looking at my scene view, and hopefully you guys have pulled up my window and created this. My ocean is what I'm looking at right here. Notice how right now the position of the ocean is kind of down here. That's just by default. But remember what our ocean does. And if I go to my script window for a second, you can see that just as a review, I've got a couple things I've done here. I've created a public floating point value, speed, just as a recap. And we've set our speed, our default speed, to 5. This represents the speed that the ocean graphic will move every frame. Okay, so how fast it'll move every frame. So our ocean sprite, which is this long piece right here, right? It's going to move downwards, right? It's supposed to move downwards 5 pixels per frame, 5 pixels per frame, which means it'll move 300 pixels down within about a minute, all right? Or sorry, about a second. I'll be okay. 300 pixels a second, right? I'll be all right. Minute, it'll move thousands. Okay, if I go back to show you what I'm talking about here, so that we set it here, right? Here's our 5 pixels per frame. Notice that public instance variables also appear inside the inspector. So if I looked at the inspector, notice how I have a speed now of 5, right? And I can change this, even though in my script I've allocated 5, and I should do. Here's what I should do in my script, by the way. One thing that I should have done better is do 5F, right? That should be what I should put in there. That's one change I'm going to make. It doesn't change this at all, but I can change this in game time. If I change it to 10, right? I can make this change as long as I'm not in play mode. It'll work. Even in play mode, it'll work, but it'll stick. So if I press play, now it's going to move much faster than before, like 10, right? And if in gameplay, now watch, in gameplay, I can modify this even faster. Let's make it 30, right? You can see that I can make it go as fast as I want in gameplay, right? But if I stop, when I stop the game, right, I'm in real time kind of debugging game mode, and if I stop, it goes back to 10 because the changes get lost between, my, kind of design state, if you will, and my play state. Now I think 5 is probably enough, so I'm going to save that. I'm not going to make any changes beyond 5. Notice that my sprite renderer, like just as a reminder from last day, my order in layer is 0, which means, and remember this, the scene itself is like a display list, right? Everything I put into the hierarchy window here, the order from an orthographic view, because we're talking about orthographic 2D, right? Everything is stacked on top of each other. So the background now is our ocean, and anything I put on the ocean is going to be stacked on top of the ocean. If I make it the same layer, you may or may not be able to see it. So we have to make sure that when we add new sprites from now on, which we're going to do now, we need to change this order and layer option to something else. Okay, so we got our ocean. I think a great thing to do is get some movement, some player movement and everything else, and I like to do the player next. Okay, so I want to get my player going, and for this, if you've downloaded my project, you'll have everything inside my sprites folder here. In my sprites folder, you're going to see a bunch of sprites. One of them is a plane, not plane 1, 2, 3, just plane, right? That's the one I'm going to use. If you don't have my assets and you're rebuilding them because you have Unity 4 and you want to rebuild your project with my assets, again, I have on GitHub. If I go to Centennial College, I think I have something called MP Assets. So if MP Assets, there it is, MP Assets under Centennial College, and all that is my audio, fonts, and sprite assets for this 2D game. All right, so you can always download these things and recreate your project just from here. MP Assets. If somehow you're Unity 4.x and you can't make my version of Unity 5, the Unity 5 project work for you. Okay, cool. So here's my stuff, and I want to pull my plane. This is how we make. Remember, we made this object. There's a couple ways. Last time I just pulled it from here from my sprite into my hierarchy like this. But remember, we have to make some changes to our object here. So let's click on our plane. Notice on the right, we did this last time, but I'm just reviewing, okay? Notice on the right, the texture type. And the texture is a 2D image. That's what it is, right? A 2D image. By the way, when we do 3D, textures on our objects are still 2D images that we're going to wrap around our objects, right? That's what textures are. So our texture type is 2D and UI. Sprite mode is single. Sprite mode means how many objects, how many sprites. This is, by the way, this is a preview of what our sprite looks like on the bottom right-hand side. How many sprites are inside of our file? Only one sprite in this particular case. That's why it says single. We're going to talk about multiple sprites and a sprite sheet in the next project when we do assignment 2. Okay? Our packing tag, there isn't a packing tag. Our pixels per unit. This is critical for us because remember, we're making a pixel perfect game, right? Our pixels per unit is 100. Is that correct? No, we have to. This is a 100 to 1, which means our plane will appear to be very big or very small, right? Depending on how we're doing it here. So I want to change this to 1. So we change this value to 1. Pixels per unit has to be 1 for all of our assets. I'm doing it one at a time just so that you can see it again. Generate bitmaps, we'll leave on. We'll change filter mode from bilinear to point, no filter. All right. Now you may not have this option if you're using Unity 4. Don't worry. And the other thing is my maximum sprite size is 2048. I'm leaving it as is. I could certainly reduce it because my sprite is only 65 by 65. It's pretty small, right? Let's click apply. And what it's going to do is apply the changes to my sprite itself. Okay, cool. Again, the easiest way to create an object here is to drag and drop. And we did that for our ocean. And the ocean added 2 things. Well, it added the default transform, and we also added in a sprite renderer. Let's make an object from scratch in this particular case. We'll make our plane, right? Our plane object from scratch. How do we do that? So here inside the hierarchy, you can right-click and create an empty object. That's one thing you can do. Or, that's one option. The other object, and now notice this 3D is a 3D object. There's a create an empty object, there's a 3D object, and there's a 2D object. I could also use a sprite, right? So those are the 2 options, but we can make an empty object though. So here's create empty. I could do that. Let me just delete that for a second. That's one option. Option 2, if I go to my game object menu, I could create an empty object. I'll also do the same thing, right? So that's 2. Option 3, drag and drop. Right? I could do that too, right? I'm gonna do it with the empty game object this time, though, okay? Just to make it so it's different. So right-click, we're gonna create an empty object, and in our empty object, we're gonna rename this thing on the right here in the inspector to plane with a capital P. Okay, look at my position. My position is 14 and minus 707. That's way off. So one thing to do always when you add a new object, and I recommend this, is go to the little gear on the right and reset. This resets the object to the middle of the screen. Now I can't see my object in my scene, and it's empty, so I'm not going to see anything, right? So if I press F to view in there, it's going to take me right into the middle of space, right? Because you can't see where it is. All right, so my object is physically there, but it's just, it's in the 0, 0, 0 position. Notice that my ocean is 0, minus 480, and 0 because of the way it's positioned, but that's okay. All right, cool. What's the next piece that I need, right, to add in to make this a sprite? Sprite renderer, right? So I add a component. This is the default way of doing it, okay? Well, oh man, is it under rendering maybe, right? There it is, sprite renderer. What if I couldn't find it here? What's a quick way to do it? I could go add component, go to here, and start typing sprite in the search bar. So sprite. Notice that it only gives me one option, sprite renderer, and that's what I want to double click, right? Or click. Okay, cool. So I've got my sprite renderer component, but I have no sprite. So how do I do that? Well, I can connect it from my sprite assets. I can drag and drop to where it says none, sprite. So I'm going to take my plane, not plane 1, 2, 3, just plane, and I'm going to drag it. Notice how I'm dragging it. It's a texture 2D object, and when it turns blue, like this, I can drop it. If it doesn't turn blue for you, something's wrong, right? So I'm leaving it there. So now I've got my plane object here. Notice how it does appear now in the scene in the very middle, right? It does appear in the scene. Okay, cool. Let's take a look at this plane object. I'm going to zoom into it. How do I zoom in again? What key? F for frame select mode. Okay, that's pretty close. I don't want to go too close. If I click the W button, or click this little button here that looks like arrows in a cross, I can get my manipulator arm, or my tool here, right? And notice how in the scene my plane starts in the middle. I don't want my plane to start in the middle. I want it to start in the lower third of my screen. The good thing is that the place that my object, right, the place where my plane is actually registered, the registration mark, if you point, or the focal point, is right in the middle, right? That's right in the middle of my screen. Do I change that focal point here in the game object, playing game object? The answer is no. We change it in the sprite. So if I go to my sprite itself, here's my plane. Notice how in my plane itself, my pivot is center, right? My pivot is center. I want to keep it center. But if you ever wanted to change this, you could change it to different positions on your actual sprite itself. You may have to do this for assignment 2, by the way. But for now, my pivot is center, right? So that means in the direct center of the plane. Now remember, the center is where 0, 0, 0 is in my scene. This is 0, 0, 0, right? And I want to pull it down to about minus 215. I know you're going to say, where do you get that number from? I've done this before, right? So if I go back to plane, right, and if I change, which value am I changing here? What's the green arrow represent? Y, right? And this is my X, the red arrow, and there's actually the blue arrow, which you can't see. It's pointing right at us. But this green arrow is the Y, so if I go to Y and change this to around minus 215, you'll see that it goes almost at the bottom, right? Let's take a look and see what that looks like in the game. Let's take a look. So this is the plane. That's kind of low for me, right? That's maybe a little bit too low. But that's like the very bottom of the screen where the plane is flying. So let's go back to the scene. And let's drag this up just a touch, right? Because I think 215, plus, the plane height, which is 65 pixels roughly. It's probably a little bit too wide. I'm going to probably go up about, let's say at least 15. So let's say minus 200. Let's try that out. That's a little better. So it's minus 200. Okay, cool. I want to move the plane, right? And in order for me to move the plane when I'm playing, I have to use my input manager in order for me to do that. My input manager. I want to use the keyboard, right, to move my plane, right? And that's what I want to do. Now, if I press play just the way it is, if I press play here, notice how the plane looks like it's flying, and the fake shadow, because I've got a bit of transparency on the actual sprite itself. You can see that it looks to be that the ocean is behind the plane. And you know what? We're lucky that it's appeared this way. But I want to make sure that it appears this way. So let's try this out. I need to change my order in layer for the plane, right? Now, you might think that 1 would be good. And for now, it would be. Let's change it to 1. We're going to change it again. You're going to see why. And I'm going to save. So for now, 1 is fine. 1 puts our plane above, for sure, 100% above our ocean. It doesn't put it on the ocean or in the ocean. So far, we're good. All right, and it does look like the plane is moving around or flying, but it doesn't. We have no control over the plane right now. And how do I get control over the plane? I have to write a script, right? Where am I going to attach a script? Am I going to attach it to, like typically in C# we have a program or driver. Would I have that here by default? No, right? I have to attach my script to my plane. Each object then could have different scripts or the same script attached to it. Because the script, I want you to think about a script as an object. I know it's kind of weird, right? But script itself is a component, right? So I can reuse the same script over and over again if I wanted to, right? Now, it would make no sense, right, to use my ocean script for my plane, because that means it'll just keep looping like this over and over again. But we're going to make something very similar for the islands and the clouds, and we'll see that in a bit. So I need a new script. Okay, again, 2 ways of doing it. I could click Add Component and go down to, let me erase this piece, and go down to Scripts, right, and select the script that's already there, or I can scroll all the way down. If you keep scrolling, and that's one problem with this window, there's something called new script. So I could select an existing script. When I go to add component, I could go to new script, which is what I want to go if I scroll down enough, right? Or the other option is I can go into my scripts folder. Notice I have my Ocean controller there. And I could right click and create a new C# script, which let's try that this time, as opposed to like adding a new component. So we have a new C# script here. Okay, cool. I've got a new C# script. I'm going to call this. I know. I know it's going to be like, shocking to you that I'm going to say plain controller, but plain controller is what we're going to do, right? And it's going to automatically put a CS at the end. You won't see it, but if you just call it plain controller, it's okay. Now, my plain controller is not attached to my plane. So just before we start doing anything with it, I want to click on my plane object, and I want to drag and drop my plane controller script onto it. A couple ways to do that. I could do it this way, but that's dumb, because you might hit the ocean instead because it's so big. But this is probably the easiest way. Just go over here and do it and drag and drop. Or now that the plane controller is there, we could go add component, scripts, and choose the plane controller script. Either way, there's different ways to get to it. But we want to add it as a component to our object. If we don't have a script as a component to the object, we can't do anything with it, right? So let's add it as, we'll just add drag and drop it in this particular case until the plus sign appears, right? This little plus. So now we've got our plane controller script attached to the object, which means every time I refer to lowercase game object in my script, it refers to the plane. That's what it refers to, right? Because my script is attached to it, right? Same thing when I say this. When I say this, it's the this keyword in C# for this script only, right? The context is the plane and the script attached to the plane. All right, so be aware of that. It doesn't mean the ocean. This is a specific script for the plane only. Notice how when I double click, I have the same two methods. That was one of the questions I asked you on your test. The two methods that start you off, start and update. Again, start is a place where we kind of initialize some values, right? Like for example, the plane speed or anything like that, right? And update, in update, we do things like what happens when, as an example, every frame, what happens every frame for the plane, right? So where would you think that I'd want to listen from my input, right? I'm going to listen from my input. Am I going to put it in my start to listen from my input? Update. It's probably where I want to put it. So this is where I'm going to listen from my input. And I'm going to use the input manager. Now, before I write my script, I want you to go here, and if I go to, again, there's a window, right? Here's window, and the window gives you different services and so on. And the other thing is, if you go to Unity itself, you notice that there are preferences, right? That's one. Under File, you can save and open your files. Under Editor, though, which is where I want you to look, if you scroll all the way down, you see that there's project settings. So Editor, Project, or Edit Project Settings. And go across to Input for a second. Input. This is important. When I put it up on the inspector, notice how I have something called Axis. Okay, cool. And notice how under the axis, my size of my axis is 18. We'll get back to this in a bit. It's kind of weird. We have our horizontal axis, and we have our vertical axis. What's our horizontal axis? Right? It's across the x-axis. That's what it means. And our vertical axis is across, in this particular case, the y-axis. So that means I want to kind of access, no pun intended, the horizontal axis, right? That's what I want to do. I want to use the horizontal axis to move right and left. Okay, cool. And you notice the buttons. If I was going to use my mouse button, right, it tells you what I'm looking at. My type is key or mouse button. My axis is the x-axis. My joystick number is get motion from all joysticks. I could change that to only joystick 1 or whatever. This is how you set up your input devices, right? I can invert my axis. I can snap to my axis. I can add gravity. So when it goes back, when I tap the button, it goes back to 0. Or when I use my joystick and I push it to the right, If I let go, it goes back to the middle, right? So I'm going to get a positive and negative value from the axis. When I press one button, I'm going to get a positive value. When I put the other button, I'm going to get a negative value. And depending on the value that I get, I'm going to move my plane. That's how it works, okay? So I'm listening for this input. Here's the input manager. And I'm going to use the getAxis method to do that. And if you don't know where it is, if I want to give a model for this, let's take a look at our Unity scripting, right? So if I say input.getAxis, right, and Unity 5, right, it's going to take me to the getAxis method right here, and it tells you how to do it. Actually, this is a video on how to do the getAxis. This is not what I want. But it does give me some ideas of how to put this together. Notice how it's an update. And I'm creating a floating point number. Here it is right here, a floating point. And this is H for a horizontal. We're just going to call that input or something like that, or key. Input.getAxis, and we're going to use the, in quotations, horizontal to say, hey, listen for the horizontal axis, okay? And this value, this H, is going to get a number between +1 and -1. Notice how there's different options here for C#, JavaScript, and Boo. We don't use Boo, and we're not using JavaScript, so please only use C#, right? Okay, cool. Now it's using a vector3 object to transform things, and we're going to have to do the same, but we're going to set up a speed of how much it's going to transform the object, and we're going to add to the existing location of the object just like we did before, right? So that's one of the things we're going to do. Okay, let's try this out. So remember, we have some kind of floating point number that's going to receive the input from our object, right? Going back to scripting. Now, if I set it up here, that means that floating point number, if I put var and I create my, if I declare my floating point variable in here, that means it'll be created and destroyed every frame, right? Is that a good thing or a bad thing? It's kind of a, you know, there's two camps on this one. One of them says it's good because that means if you don't need it, it doesn't exist. If you don't press anything, there's no container, right? On the other hand, it's always creating and destroying all the time, right? So I'm not really keen on that. I like to create it, and I'm going to make this thing a private variable because we don't need to know what it is outside of this script. So I'm going to just give it a little annotation here, a little comment. So private instance variable. Kind of type that in, and you should type along with me. Don't watch. Type along, so you guys get used to writing scripts with me. All right, and then my private instance variables, I'm going to use this private and floating point variable that I'm going to call what? Something like, you know, player input or something like that. Let's just call it player input. Player input. And I'm using the underscore only as a convention. You don't have to. I am for all my private variables, right? Okay. Now, notice how I've just declared my variable, but I'm not using it yet. Down in here, if I want to access my variable, just like normal C# rules, I could just do one of these, player input with like this, right? I could write it like this. But I'm asking you to use the this keyword to really be specific. So I'm going to say this.player input, which means this variable here. This.player input, right, is equal to, and here we go, here's my input manager, input, right, dot getAxis, here we are, and in bracket, in quotations, horizontal. You got to spell it correctly though, eh? And there's no code hinting for this one. Yes. Sorry? This? We use this keyword, if you know C#, this refers to the variable that belongs to the actual class itself, this plane controller class we're making, and it also refers to the object itself, right? So in this particular case, this keyword refers to the new variable we've created in this script, right? Think about a variable as a container that's now attached to the plane object, right? This little data container, right? All right, cool. So every time we click the horizontal buttons, and by the way, the horizontal buttons on your keyboard are, by default, the right and left arrows, and A and D on your keyboard, those two buttons, right? So let's check this out. I want to debug.log to see what I get. So I'll say debug.log. And in debug.log, we'll send out this underscore player input to see what we get. All right? And you check this out for yourself. So tell me, run the script, and see what you get, and see if you get an error. See what happens. Tell me what happens. I'm not going to run it before you guys do. Go ahead, try it. Here's my plane. Here's my script. Notice I don't have anything in the inspector because my variable is private. Only public variables appear here in the inspector, unless I specifically serialize them. If I serialize the variable, I can make it appear in the inspector, right? By making it serializable. We'll talk about that later again. I kind of did it. So tell me, what values are you getting when you press your buttons? Are you getting any values? Huh? 1 and -1. Okay, 1 and -1. I got that answer. Let's check this out and see what happens. So positive and negative values. All right, so let's try it out. And you should get 0 too. 0 means nothing's being selected, right? So let's check this out. Let's run, and let's see what values I'm getting. And notice right now on the bottom, and it's hard to see for you guys, but on the very bottom of your screen here, on the bottom left corner, you see almost like a little output of what the debug is saying. If I want to see my console, you need to include the console window in your workspace. And to do that, you can go to Window, right? And if you like, all the way to the bottom, Console, or press Shift and the Mac Command C, and I believe it's Control C on Windows, right? Okay, so now you've got your console. You can see that every frame I'm getting 0, right? Okay, cool. Now I haven't selected anything, so let's press the right arrow key. So right arrow. Okay, and then I keep doing it, right arrow. And if you notice on my console, what happened was, well, it's gone, right? But if I scroll up a little bit to see what my thing is, it's really quickly gone. But I can tell you that it's, oh, there it is. It is positive numbers up to and including 1, right? That's what my arrow key is giving me, right? Same thing on in the other direction, right, as an example, for my other one. So if I go back to Game and I press my left arrow, I have to be centered in here to do this, not over here. In here, in the game. And if I press my left arrow, I get a -1. So right arrow and left arrow. If I do the same thing with A, D and A, both those keys give me positive and negative numbers. Well, great. That means I have input. It's listening for my input, and now I can respond to this input. So here's what I want to do. When I press the right, listen to my words. If the right arrow or positive numbers are happening, right, I want to move my plane to the right, X number of pixels, right? If the left arrow or left key is being pressed and I get negative numbers, I want to put my plane to the left. How do I write that? How do I code it? And what's the right way to do it? There's many ways to do this thing, but how can I do this thing so if I press the right arrow or the left arrow, I get different motion? Right. I could do what? Well, no, I'm saying I want to write the script to do it, right? But how do I write? Show me, help me write this thing. Yeah. I got the value because the value comes from my player input. My player input has the value, positive or -1. Okay, now what do I do? I could, but I need some kind of if statement, right? I need some kind of way. I still need a conditional. If it's a positive 1. Okay, all right, that's one way of doing it. Let's try it that way, right? And else if the input's the other way, right? Else, what happens when you have 0? You don't do anything, right? So you can actually just test for both positive or negative. You can do that. All right, so let's try this out. So let's get rid of our debug.log, so we don't need that anymore. And in my script, I'm going to start typing if this dot underscore player input, right? And again, is greater than or equal to 0, greater than 0, greater than 0, right? Then we know we're going to move to the right, right? We're going to move to the right. And then if, here's another if let's just outline this thing, this underscore player input is less than 0, right? Because that's the other condition. Then we'll move to the left. We're not going to make a condition for 0 because you don't want to move for 0. If it's 0, if no one's touching the keyboard, you don't move, right? So you don't care about that condition, right? So we don't listen for it. All right, so this is kind of move to the right. This is move to the left. Okay, cool. If I move to the right, how do I remember my position of all game objects is governed by the position. So I have to be able to kind of attach or connect to my component. And my component for position, rotation, and scale, right, is my transform component. My transform component on my plane gives me those things. And my Y position, that means up and down, Never going to change. So I'm not going to change that. I'm only going to modify my X position, right? And it's going to be my transform position. So there's a couple of things I can do. I could make a reference to my transform, right? Which is what I recommend you do. And then we're going to hit the transform position. Okay, now this is what I want you to do. There's different ways of doing the same thing, and in the videos they'll show you different ways. But I want to create a private reference, right? And it's going to be of type transform, because transform is a data type, right? And we're going to call this the transform. We're going to use underscore for the transform. And what I'm doing here is I'm setting you up so that way in the future we can drag and drop a transformation or transform component from another script. I don't have to do it this way for my own script, but I'm going to make you do it, right? All right, so I've kind of made a transform variable, but right now it's just the shape of the transform data type, right? And the transform data type means this component. This component includes position, rotation, and scale. Yes?
With the script, right, I actually have two questions. One, why is it you use two ifs instead of an else if?
Because else if says this. If this, then else if this. I want to always check both every frame. Because I could have both buttons being pressed at the same time, right? And I can go from one button to the other, depending on which button is being pressed first, right? In the future, you might have multiple buttons being pressed. For example, your up button and your right button. And you don't want to say if else, because only one button will fire, right? This way, every button can fire at the same time, right?
At the same time, you told me whichever is first, it works. Right?
In this example, yes. But in other examples, if I have the up button and the right button being selected, which way is it going to go? This way, right? So that's why I want you to start like this. Not because your way won't work in this example. Remember, there's many more ways to write this thing. Yes?
I have one more question. We don't have any event handlers for keyboard inputs? Like
This is the event handler. We're actually using the input manager, which handles all our event handling.
all the event handlers?
For everything, any kind of event, well, all the input events. Any kind of input devices, mouse, keyboard, joystick, controller, like if you have a gamepad or something like that, all those kinds of inputs, VR device, virtual reality device or whatever, all happens through the input manager. Okay? Okay, so, and we use the input to access the input manager. We can also write our another input manager class. We can modify the input manager so we can get input from mobile devices as well, touch devices. But for now, there is no touch input. Okay. So input.getAccess horizontal, we've done this, right? If there's a touch, we want to move to the right or left. And we want to modify this transform. But let's make a reference to it first. So first we're going to say this dot underscore transform then is equal to game object, lowercase, not the uppercase game object, the lowercase game object, which refers to the plane, right? Dot. And we're going to use the get component, right? Get component method. So we're going to get the component from our game object, which is of type transform, right? So what we're doing here is we're making a reference to the transform component, and we're storing it, a pointer to this component inside of our transform object, right? That's what's happening. So this transform now basically is the transform inside of our game object. That's what we're doing. It's actually a direct reference, right? So I can use this new variable here, this variable that's inside of our class, underscore transform, to access, right? To access this game component which is attached to our plane. That's how it works, okay? All right, cool. So that's the first thing I've done here. Next thing is I want to understand my position. Yes?
Do we have to use game objects, or can we just do like game components?
You could do gate components, but I want you to do it this way because in the future we're going to be dragging and dropping other objects from other scripts and other game objects together into one script. And if you're used to doing it this way, right, it's not going to be a problem for you. Do it the other way, it's going to mess you up. So you're going to see different ways online. Don't worry about it, but keep in mind that game object lowercase refers to the game object that this script is attached to, right? Okay, cool. So here's my game object. I've got a reference to it, and again, this is one way of writing it. There's different ways. I want to also know, I have to know my current position, like we did last time for my ocean script. Look at my ocean controller. In my ocean controller, we have a vector2, which is a current position that I used. I'm just going to copy this. So I'm going to say current private vector2. I'm going to go back into my plane and just paste it. So vector2. Now this current position is not the same as this current position. They're in two different classes. And again, each class encapsulates its own variables like in any other C# code that we use. And notice what we did here. We said in our update, I said my current position is this transform position. I want to use the same code, right? And we also have a speed component, which I'm also going to use because my player is going to move at a certain speed. So let's get this public float speed variable. It's almost the same, right? Almost beggars to say that we can almost write a script that can be used for both my ocean in some ways and my player. And then add other things, almost like inherit from this other script. We could do that. We're not going to do that here because it's going to confuse you even more. But for now, let's just make a public variable that we're going to put up here exactly that is called speed. We're going to make it a speed of 5. You're going to notice the speed of 5 is way too much. But let's put a speed of 5 in here, right? And what I want to do, just like I did in my ocean controller here, is I want to say, in my update, I want to say, well, this dot current position, this my current position, is equal to this dot transform dot position, the position of the plane where it is at that particular moment in time, right? So I need to get that information. And I want to do that when we first start our update, just like this. Go back. So before I check to where it is, before I check what I'm pressing the button, I want to set up my update. So at the top of my update, my current position of my plane, I know my current position. Okay, cool. And it's going to reset this every frame. So my current position is this, whatever position it is, okay? What I want to do is, depending on whether I press right or left, I want to add a vector to my current position and then modify my transform position along with it. That's what I'm going to do, right? So add a vector. All right, so remember, we're going to make a new vector. So here's how we're going to go. So if I go to the right, I want to say, well, this dot underscore current position, right, is plus equal to, so I can do this, it's just a vector, right, is plus equal to a new vector2 object. Vector2 only has two components, x and y, which is going to add to which component? Not the y, because I don't want it to move across the y. It's going to be only the x. And it's going to be of speed, right, to the right, positive number, right? So it's going to be this dot speed. And then on the y, we're not going to add anything to it, so we're going to leave it at 0. Right? Because if we add it to the y, then it would move up too. We don't want that, right? Or something else. So that's one thing. And then after we change our current position variable, it's just a holder, a placeholder for our current position. I'm going to make our actual position, which is the transform, the get component. I'm going to assign our current position to our component. That's the only way I can do it. I cannot modify my component directly. I can't say my current position dot x is equal to blah blah. I can't do that. It will give you an error if you try it. Okay. So I got to do this. I got to say, so this dot underscore transform, as an example, dot position, right, is now equal to this dot underscore current position. That I can do, right? Well, I'm always going to do this, right? This dot transform position is equal to this dot current position. I'm going to do it here, and I'm going to do it here. And that means I'm going to duplicate my code. So couldn't I do this piece here, right? Because regardless of what's going to happen, I'm going to make it equal, regardless, right? Whether I do this check or don't do any check. It's going to be the same anyway. It's not going to hurt me to do it here. So I don't have to duplicate my code. But this piece here is going to change, right? So let's copy this one and put it into the negative over here, right? And instead of using this speed, it's going to be minus this speed because this one is going to move to the right and this minus speed is going to move to the left. I'm adding a minus, which means I'm subtracting, right? So plus equals to minus. Or I could do it like this. Instead of plus equal to, I could do this minus equal to. It's the same, right? All I'm doing is adding or subtracting a vector, an x component. I'm leaving the y component alone in this particular case. This might be confusing to you, and there's different ways of doing it. But you'll see in the future that if you do it this way, it'll be easier for you later. Okay, cool. So I've got this going. I'm going to move to the right and left. I'm going to update my position depending on which button I press. And if it's positive, I'm going to add 5. If it's negative, I'm going to subtract 5. And I only have one speed value, which is 5. Let's see what this does for our plane. Right? I'm going to save this script. I'm going to go back out here. I want you to test it, and you tell me what happens. Test the script out, and it's gone, right? It's gone. Let's see what it does, why it does that, because that's a problem, right? That's really bad, right? Why does it do that? And let's press to see what this does. So I'm going to press play, right? And here's my plane. I press my right arrow, and then, okay, it's cool. And it doesn't move that fast, actually. Take a look. So I move my right and left arrows. It keeps on moving. Depending if I touch it, it does move it a little bit. So 5 seems to be the right thing, but then she's gone, right? And if I keep moving to the left, she comes back. What's really happening if I move it to the right, beyond the screen, it actually, the scene, right? And if I move it to kind of expand, it's way over here, right? That's where the plane goes. Do I want to let my plane go over here? No. So the next thing I do is I have to check to see where my plane is. And if my plane is at a certain point, I have to check the boundary is what I'm doing. If I check the boundary of my screen, if the plane is at the right edge of my boundary, I want it to stop. Right? That's what I want it to do. And that's going to happen after I change my transform. Right? Well, after I add to it. But before I assign my current position. Right? Because it doesn't make sense that I would add my current position and then check it again. Right? Makes no sense. So let's go back and let's fix this problem. Well, one thing I want to do is understand what my boundaries are. Right? So let's go back in here and check my plane out. So right now my plane is at 0, minus 200, right? If I move my plane in the scene, let me see if I can make this a little smaller for you so you guys can see it, and I'll zoom in a little bit more. I want to move this just virtual. I'm going to try it out. So if I move my plane, I don't want it to go beyond, let's say, something like this. Look at what my value says, 291, right? So 291 to the right. And I don't want it to go farther than, let's say, I'm ballparking here, about 290. So it looks like minus 290 and 290 is the right value. See that? Minus 290 and then 290. I don't want to go beyond that. So that's where I wanted to limit my plane. I don't want it to go beyond that point. I'm already limiting it on the y-axis, so it can't move up and down. It can only stay fixed there, right? So let's put this back to 0. And let's go back into my script. And inside my script, again, I do my checking. So this is where I'm checking to see if I'm moving right or left. And let's put some comments in here to see that. So, move right as an example. And this is our move left, right? Move right, move left. If these numbers are thing, then move right. So I can say that if, here's our pseudocode, if player input is positive, then move right. And then if my player input is negative, move left, right? That's what I'm doing here. So now what I want to do is say check to see if I've hit a boundary, right? If I hit a boundary, if I hit the right boundary, reset my my current position, right, to 290. If I hit my left boundary or go beyond my left boundary, reset my player position to minus 290. Okay, that's what I want to do before I transform it, by the way. Yes? Say that again? If it's less than 290, it's only the left side of the screen. Oh, I mean less than 290, yeah. So only if it's less than 290 is what you're saying, right? Yeah, but that means, what about if I go beyond minus 290? That's less than 290. There's different ways of writing it, for sure. There's different. I mean, you could pull for where the plane is, and if not, then you're not listening for input, is what you're saying, right? You could do it that way, or you can do check bounce. So let's say if I say if my current position, this dot underscore current position current position, right? Dot X is what I'm checking, X. Because we're only checking, we can check, I can compare the X component of my object, but I can't modify it. So if my current position X, right, as an example, is less than, you know, minus 290, so if it's to the left, as an example, I'm just checking the left one first, then what am I saying is this dot underscore current position is equal, dot X, is equal to minus 290, right? That's the only condition that I want to make it, so minus 290, right? And at the same time, I'm checking both. If this dot underscore current position, I'm making it easy too, X is greater than 290, right? Then, I'm just going to copy this one. And you can see there's ways of optimizing this. That's equal to 290, right? Okay, so that's one thing I'm checking. So it won't allow me to go beyond. So, you know, check if the plane is going out of bounds and reset, and keep it in bounds. Keep it inside boundary, screen boundary, window boundary. Again, I'm just putting in some pseudocode so you understand what I'm doing here. All right, so this is my script, right? I'm going to go back to my Unity window, and I'm going to press play. And let's see if it gives me an error or stops me from, hey, I'm moving here, and then it stops, and then I move over the other side, and then it stops. Same thing with my arrow button. So now it wouldn't even go by. Even if I press the button, it's always resetting back to 290 or minus 290. So it's stopping my plane. You won't be able to go. That's kind of a key thing. If I don't do that, then my plane can go anywhere I want. So I've got plane movement. I think we've been pretty successful at this. There's ways of breaking this out a little bit. And if I ever wanted to reuse this piece, a check bounds, is that a question you have? Okay. Then I could certainly extract this into a method, a check bounds method. And it might be more human readable if I do it. Not because I'm going to reuse the method, but because it'll be human readable, right? So if you're using Visual Studio, you can right click, as an example, refactor, even monodevelop, and click extract method. And in this particular case, it says use refactorings on this solution. Warnings, the Xamarin Studio refactoring operation is not yet supported in C#. I'm not using Xamarin Studio. Well, it tells me what I want to do. Use up, down to move to another location. That's not really working on monodevelop, so I'll just do it by hand, right? So I'll say, I'll call this thing, again, look at the method. It's definitely going to be public, right, or private. I can make it a private void. It's not going to return anything. Method called, because it's private, I'm going to make it use underscore, and it's going to be called check bounds. So when you write the check bounds method, here it is, right? So these are our, we'll call them these private methods. These are private methods. We might write more than one. Here it is. Okay, private methods for check bounds. And what we're going to do here is we're going to take this code right here and extract it. We're going to cut it out and put it inside of our method. There it is. And then we're going to reference our check bounds here. So we're going to say this dot underscore check bounds. Right? So what this is to you now, you can look at it and say, I'm going to check my boundary. Check my boundary, right? Which is, that's what I'm doing here. And this, right, what I'm doing here is check your player input. You know, move left and right, right? So I could make, if I wanted to really be crazy, I could make, you know, move right or move left. But I'm not going to do that because it's overkill. But you could make other methods here. But this is a great example of how you can extract a method, not because you're going to reuse it ever, although that's really why we extract methods, but because it cleans up what we're doing here, right? First of all, let's try this out to see it works. So press play again, because if we ever make a change to our methods, right? So I think our plane is complete in the way I want to get it right now, and I want to upload this to GitHub, right? So the way to do it again is in Unity, I'm going to save my scene. I'm going to close down Unity. That's the right thing to do, right? I'm going to go into my, I'm I'm going to go into my command line here, but I need to know where my Unity is, right? So, I mean, I know where it is. Let me just pull up my command line here. So here's my command line in Unity, and I'm going to swim to my desktop. Inside my desktop, I know I have something called Unity Projects, and I want to go to COMP305, oops, and it's going to be our Mail Pilot, or Winter 2016, Mail Pilot build, right? There's my Mail Pilot assets. And I'm going to say a git add dot, oops, which adds everything to my Git repository that I just changed. And I'll say git commit minus m for message, and we're going to call this thing added plain game object. That's what we just did, right? And with the script and everything else. And then what I'm going to do, I'm going to clear this up. And then what I'm going to do, I'm going to say git push minus, or not minus u, but git push origin master. And what it's going to do is going to connect to git and push this up there. So now you have everything that I have. And to check that out, if you go to your Git repository here for Centennial College, notice that W2016 Mail Pilot is updated, and it says added my plain game object. So if you wanted to see what I did, you can also always go into assets and scripts and look at my plain controller.cs file, and you can see that this is all the code we just wrote together. Okay? I'm going to pause the movie here, take 5 minutes to get a little bit of a bio break, and then we'll come back and we'll add an island to our game. Okay? Let's do that.